This is chapter number 5, and the title of the chapter is Energy, Work, and Power. So, this diagram is showing that one person is pushing the wall. So, this is a kind of the mechanical work. And here also, the work is shown with the help of the diagram. Here, one person is pulling the box with some force, and he is displacing the box up to some distance. So this person is also doing the mechanical work. This picture is showing also some work is done on this box, and here also the work is done by this animal. No. So our main chapter starts from here. This is the formula for the work. The W equal to F multiplied by the displacement multiplied by the cosine theta. So in this diagram, one person is pulling this box up to some distance or the displacement. So he is applying some force on the box at some angle. So this is the direction of the motion. This is the direction of the motion. In this direction, the box is displaced. So basically sometimes we are showing the displacement. Okay, sometimes we are showing the displacement by the d, or sometimes like in this formula we are showing the displacement by the del x, but both they have the same meaning. So in this formula, the F is the force applied on the box, and the del x or the delta x is the displacement here. Like from here to here, this is the displacement in the box. And this theta, this is the angle between the direction of the force and or the horizontal direction or the direction of the motion. So this is the angle theta. And the work, the unit of the work is joule. So here the maximum work is shown. See, we have this formula for the work. The W is equal to the force multiplied by the displacement multiplied by the cosine theta. So this is our normal formula. Okay, but sometimes the work is maximum and sometimes the work is minimum. So what is the condition? Okay, so what is the condition for the so here what is the condition? Okay, the rule. So what is the condition? So what is the condition for the maximum work? So the condition is it is shown in this diagram. So the person is pushing this table. So this is the table, and this is the direction of the force, and this table is displaced. Okay, so this is the direction of the displacement. So here the angle between the force and the direction of the motion or the direction of the displacement is 0 degree. So this is 0. They are parallel like this. This is the direction of the force and this is the direction of the motion or the direction of the displacement, like that. So here the angle is 0 degree. So the theta is 0 degree. And if I put this theta in cosine here, so the cosine 0 degree is 1, the plus 1. So in the cosine table, this is the maximum value of the cosine. Okay, so if it is like this, so if the person is moving the object like this or like this, okay, so in this case the person is doing a maximum work. Okay, and this is, and the value of the cosine theta is 1. So this is the formula. Okay, the W equal to F multiplied by delta X. So this is the formula for the maximum work. So in the similar way, the work is minimum also. The work is minimum or the zero sometimes, or the minimum value. Okay, so when it is minimum, actually there are two conditions. Okay, for the work to be minimum, there are two conditions. Okay, for the work to be minimum, this is the case number one. Okay, so it is case number one means like one type I can say. Okay, so when the work is minimum, so you can see in this, okay, in this diagram here, the person is lifting a box, okay, by some force, okay, lifting a box, and this person is moving in this direction. Okay, so this picture is representing, okay, like that a person is moving, okay, on the ground by holding a box like that. Okay, so here, so this is the formula for the work. Okay, the W equal to this is F and the delta X, and this is the cosine theta. So here we have to see what is the angle, what is the angle between the direction of the force and the direction of the motion. So here the angle is 90 degree. In this case the angle is 90. Okay, so here if I put this 90 in the cosine, so the cosine 90 degree is 0. Cosine 90 is 0. Okay, so if I put this cosine 90 0 here, so the work is going to be minimum and the value of the work is 0. So this is the one condition, okay, for the minimum work. So this is, okay, this is case number one. And there is a one more case. Okay, there is a one more case when the work is, okay, when the work is 0. Okay, actually in this case, okay, in the case number one, the theta here is 90. So due to theta 90, this work is 0. This is the thing here. Okay, and in the case number two, okay, in the case number two, like this is the formula for the work. Okay, the W equal to multiply by the displacement, and here this is cosine theta. Okay, this is the normal formula for the work. Now in the case number two, okay, in the case number two, in the case number two here, they are saying the object is not moving. Okay, the displacement, okay, of the object is 0. So displacement of the object is 0. What is the meaning of this? The meaning of this means if the object is at rest, okay, it is not moving. Okay, so if the object is not moving, okay, then this is 0. Okay, so here because the displacement is 0, so that's why here the work is 0. So these are the two cases. Okay, so when the work is 0 or the work is minimum. Okay, so in the case number one, this is the condition. Okay, theta is 90, and the case number two, work is 0 or the minimum, but the condition is different. Okay, so what is the different condition here? They are saying, okay, the rule says here the displacement is 0. Okay, the object is not moving. Now here there is a small problem, okay, on the formula for the work, and here they are asking, okay, how much work is done, okay, how much work is done by the boy pulling his sister 30 meter, okay, in a wagon as shown in the diagram. So this is a wagon car, okay, in which okay, one girl is sitting, and assume no friction acting on the wagon. Okay, so assume no friction. So the meaning is there is no opposite forces. Okay, no friction means there is no opposite forces. Okay, so how many forces are acting here? So we have to take the total. The meaning is like that. So here we have to find the work. Okay, so what is the value of the work, and the displacement is given. So okay, so if you find the solution of this, so what is given here? The given is the displacement. Okay, actually don't be confused. Okay, sometimes as I told you, okay, sometimes the displacement is shown by the letter D, and sometimes the displacement in some books it is shown by letter S, and sometimes it is shown by the delta X. Okay, both are okay. Okay, all are okay. So these are the common, okay, the letters, okay, used to represent the displacement. Okay, so here the displacement is given how much. It is given 30 meter. Okay, and the force, it is shown in the diagram, and the force is, okay, and the force is 50 newton. This is given. And yeah, so the angle, okay, so angle with the force and the horizontal direction is 30 degree. So here the theta is given, that is 30 degree. Okay, so they are saying what is, so what is the value of the work. So we have to find what is the value of the, okay, what is the value of the work. Okay, so we have to use the rule. Okay, we have to use the formula. And the formula for the, okay, and the formula for the work is, okay, the formula for the work is, uh, the formula for the work is the W is equal to the force multiply by the displacement and multiply by the cosine theta. Okay, so this is there. So I have to feed, okay, the value of the force, which is 50 newton, and the value of the displacement is 30 meter. It should be meter, okay, not centimeter, and not millimeter, not kilometer, okay, only meter. The displacement should be only in the unit of the meter. And here this is the cosine theta, and the value of the theta is 30 degree. Okay, so if I solve from my calculator, okay, so I calculated the answer of this, okay, uh, equation. It will be 1299. So this is 1299, and the joule. Okay, the unit of the work is joule. Okay, so this is our answer here. Okay, for this, for the question number 1. Now this is the question number 2. This is on the same idea. Okay, but here they are asking something different. Okay, to evaluate, okay, to find. Now here a person pushes a lawn mower. Okay, so this is a lawn mower here. Okay, this is the lawn mower with a constant force of 75 newton. So this is the value of the force. Okay, 75 newton. This is the value of the force over a distance of 25 meter on a level ground. So this is equal to the displacement. Okay, and if the work done on the mover is 1.4 kilojoule, so the work done by the person, okay, on the work done by the person on the mover is 1.4 kilojoule. So this value is given for the work. Now they're asking what is the angle. Okay, now they're asking what is the angle between the applied force. Okay, so this is the direction of the force between the applied force and the horizontal direction. Okay, horizontal direction or the direction of the motion. Okay, so this is the horizontal direction. Okay, or this is the, okay, or this is the direction of the motion, and this is the direction of the force. So this angle we need to find according to the question. Now here I am writing, okay, what it is given. Okay, in the question, the value of the force is given, that is 75 newton, and the value of the displacement, it is given 25 meter, and the value of the work done is given, this is 1.4 kilojoule. Okay, so this is kilojoule, and the unit of the work is joule, not a kil. This we have to, okay, eliminate. We have to keep the value for the kilo. And in terms of okay, the joule, the value would be 1.4. Then I need to multiply by 10 to the power 3, okay, and make it in the unit of the joule. So this value we have to use, and this is the, okay, work value given. And what we have to find. Now we have to find the angle here. We have to find the value of the angle, okay, between the force and the displacement or the horizontal direction. Now okay, so we have to use the formula for the, okay, we have to use the formula for the work, and the formula for the work is the W is equal to the F multiply by the displacement and multiply by the cosine theta. Actually here I need to find this. Okay, so what I will do to make it simple, okay, to make mathematically simple, I will take this factor outside. Okay, so if I take this cosine theta, okay, extreme left side, so what it will come, okay, so this will be here only, and this will go to the other side. Okay, this is multiply here. Okay, so when I will change the side of this, it will go in the it will go in the division there. So this will be the work and divided by the force and then the displacement. Okay, so this rule we have to use for our problem here. Now, okay, so now I am writing this rule here. Okay, so this is the cosine. Okay, so this is the cosine theta, and this is equal to the work, and this is the force and the displacement. So the value of the work, the value of the work is this is 1.4 multiplied by 10 to the power 3. Okay, kilojoule you have to always you have to change. Maybe if it is megajoule, you have to change. Okay, if it is for example nanojoule, megajoule, gigajoule, okay, so this you have to change to joule all the time. And the value of the force, okay, it is given here. Force how much? Okay, so the value of the force is 75. So the value of the force is 75, then multiply by the displacement value, and the displacement value is 25 meter. So if I do the calculation of the whole part, okay, so if I calculate this and if I calculate this, so I am getting the answer. Okay, here this will be 0.74. Okay, and this is the value of the cosine theta, not theta. The question is asking what is the value of this. So how to find the value of the theta? Okay, so I'll change the side of this cosine. Okay, so I will keep the theta here and cosine will go to the other side. Okay, and I will keep the cosine here, but this will come with the inverse. Okay, when it will change the side, it will come with the inverse. And here I will put the value. Okay, this is 0.75, and if I calculate, okay, in the calculator, okay, so if I calculate in my calculator, okay, so how much I am getting? I am getting the value, okay, of this is 41. Okay, this is 41.6 degrees. Okay, so this is your, okay, so this is your answer. The angle between, so this is, okay, so this angle is 41.6 degree. So this is our answer. Okay, so the question number 3 is already solved here. Okay, so you can try at home. This is easy. Okay, so this is also, this question is solved, question number 4. Okay, this also you can try at home. This also the same idea. Okay, nothing different from the last, okay, the two problems I solved. This is also the same idea. Okay, now we are moving to the other topic. Okay, the energy. Okay, basically, okay, so one thing I want to tell, that the energy and the work, they have the same meaning. There is no difference between, if I say, okay, so if I write something, okay, for the, okay, for any formula, okay, for example, the work, okay, the work and the work, okay, the energy and the work both have the same meaning. Basically, technically, both have the same meaning. Okay, for example, okay, for example, if I write the formula for the work, okay, like this is the W equal to, okay, the force and the displacement, and this is the cosine theta. So this is the work basically. Okay, I told you. But if I write here, this is the formula for the energy, there is no harm. This is okay. Technically, it is okay. Okay, so here it is explained like how many types of the energies are there. So there are so many types of the energies. Okay, and the sound. Okay, the sound energy, heat energy, and the light energy, nuclear, and the kinetic energy. So there are so many types of the energies are there, and which are most common. Okay, so it is displayed here. Okay, so here the first line is the energy is the ability to do the work. So the energy, okay, is same like work. Okay, so as I told you, okay, on the last line, this is the definition of the energy. Okay, energy is the ability to do the work. So the main thing is this is basically this line. Okay, so if it comes in the examination, okay, so you have to write this is the definition of the this is the definition of the energy. Okay, if this is coming, so the same you have to write. As here, okay, so different types of the forms of the energy given here. Okay, this is like mechanical energy, okay, electrical, and the heat, the light, the sound, chemical, nuclear. There are so many. And okay, so here they are saying okay something about the actually mechanical energy. So we have to study okay in this chapter mechanical energy in detail. This is a mechanical energy. So what is the rule for the mechanical energy? Basically the mechanical energy, okay, the mechanical energy is the sum of, okay, is the sum of the kinetic energy and the potential energy. This is the rule. Okay, so the mechanical energy is the sum of kinetic plus potential. Okay, so here okay, so here too much information is given, okay, up for the kinetic energy, and I am okay writing in a very brief way, okay, for the rule for the kinetic energy. So there are one rule, okay, for the kinetic energy, and I'm writing here. Okay, so the one rule is about the about the kinetic energy. Okay, the kinetic energy is equal to the half the mass and the velocity square. Okay, so this is the formula for the kinetic energy. Okay, after that there is a one more rule given. Okay, that rule is basically for the work. Okay, basically this rule is for the work. Okay, so this rule is for the work, and actually here there is a relation between the work and the energy. Okay, so what it is stated there, the work is equal to, okay, the work is equal to the change, this is a change, the delta is a change in the kinetic energy. Okay, this is a work, this is a rule. Okay, now if I open this delta, okay, then I can do like this. Okay, this is the kinetic energy final minus the kinetic energy initial. Okay, so this is the difference between the two kinetic energies, the final and the initial. Okay, now what I am going to do, I'm writing okay this row, okay, here, and this row here. And I will use this final and the initial. Okay, so here, so for the okay, so for the kinetic energy final, I'm writing the rule. So this is half the mass and the velocity square, but this velocity is this one final. Okay, so I'm writing here final, and the minus half mass and the velocity square, but this velocity is initial. Okay, so this is the rule, okay, for the work done, okay, for the work. And if I okay, so if I take okay, if I make this rule simple, so what I can do, I can take this, okay, common from here. So this is half m coming here, and this half m is coming here. So what I can do, I can take this, okay, I can take this common here. Okay, easy to solve. Then this would be okay the half the mass, and in the bracket this is the velocity final square, and minus the initial velocity, okay, square, and this is equal to the work done. Okay, so this is the new formula. okay, for the work done. This is the formula for the kinetic energy, and this is, okay, I can say the rule number 2, okay, for the kinetic relation between the kinetic energy and the work done. Okay, so this is a already solved one example here. Okay, you can, this is simple. Okay, just here they're asking, okay, what is the velocity of the okay, of what, of the molecule. Okay, so this I am doing. This is little bit not very easy. Okay, so the question number 8 is, there is a 30-gram bullet initially traveling at 500 meter per second, penetrates 12 centimeter into the wooden block. What is the force does it exert? Okay, so they are talking about this bullet. Okay, so they're talking about this bullet, this one. Okay, so this bullet has the mass, okay, the mass of 30 gram, but gram I cannot use. Okay, the mass of the 30 gram, and the velocity of this is given by this is 500, okay, meter per second, and this bullet penetrates, okay, this is a wooden block, and it penetrates 12 centimeter in the wooden block. So like from here to, like from here to here, like from here to here, okay, this is the, I can say, this is the displacement here, okay, according to our, you know, our formulas, okay, our parameters. So here this is the displacement, okay, this is the 12 centimeter here. So this bullet, okay, is, okay, this bullet is hitting, okay, this bullet is hitting here, okay, this bullet is hitting here, okay, hitting here with this velocity. So they're asking, okay, so they're asking what is the value of the force. Now they're asking what is the value of the force, okay, that this bullet is hitting here, okay, here hitting. So we need to find the force. So okay, so for this question, what given to us, okay, what parameters, okay, what are the parameters that are given to us. Okay, so actually we have to find the force here. So what are the parameter given? The value of the mass, okay, the value of the mass is given, that is 30 gram, okay, but gram we cannot take. So I need to multiply by, okay, I need to multiply by 10 to the power minus 3, and this will convert to the kilogram. Now this is the velocity of the bullet, okay, and this is 500 meter over second, and there is a displacement, okay, that the bullet is crossing, you know, this area, okay, of the wood, and this is equal to 12 centimeter, okay, but 12 centimeter I cannot take, so I need to change to the meter. So this would be, okay, the 12 multiplied by 10 to the power minus 2, and this will be converted to the meter. Okay, now I know the mass given and the velocity given, so I can find, okay, something about you know, something about the kinetic energy. Okay, some idea is coming. Okay, so what I have, okay, given here, okay, so it seems that I can find easily the kinetic energy, but there is no, you know, there is no formula, okay, for the kinetic energy which is having a force. Okay, so what I can, so here what I can do, okay, so I know that, okay, I know, okay, I know that the work is equal to, okay, the work is equal to the change in the kinetic energy. Okay, this I know, and this is the rule. Okay, the work is equal to the change in the kinetic energy, but here actually only one velocity given. Okay, so normally we are using, okay, this change when there are two velocities given. Okay, but in this type of the question there is only one velocity value. Okay, so what I can do, I can modify this rule. Okay, I can modify this rule. Okay, according to our condition that the work is equal to, not change. I'm not taking the change. Okay, so the work is equal to the kinetic energy. This I am taking the rule here. Okay, the work is equal to the kinetic energy, not the change. Change we are using when we have the two. Okay, the initial and the final. But here I have only one, so I'm making it simple and removing this the delta. Okay, so here if I put the formula, okay, for the kinetic energy, so this is the half and the mass and the velocity square. I have the mass, I have the velocity. So what I will do first, I will find the value of this. Okay, so this is the half and the mass of the, okay, bullet. How much? The mass of the bullet is 30. Okay, this one. Okay, 30 multiplied by 10 to the power minus 3. So this is 30. Okay, 10 to the power minus 3. Now the velocity of the bullet. Okay, so what is the velocity of the bullet? The velocity of the bullet is 500 meter over second. So this value, okay, I need to put at the place of the v. So v, and this is the 500 meter over second, and then the power 2. Okay, so if I solve the value for, okay, so how much, if I'm solving, okay, in my calculator, so how much the answer will come? So the answer will come here. This will be, 3750. This number will come. Okay, joule. So this number I got by using the value of the by using the formula of this kinetic energy from this idea. Okay, but they are asking, I need to find the force. Okay, so this is, I know this is equal to work, and I know, okay, and I know the work is, okay, the work is equal to the force multiplied by the displacement, and this is the cosine theta. Okay, so this I know. If I find here, if I find the work from this rule, here I have the value of the force. No, the force, okay, so here we need to find the force. Okay, so, okay, so we need to find the force. Okay, so what I will do, okay, so I have the value of the work or the value of the kinetic energy. Okay, this number. So what I will do, this I will keep here. Okay, so at the place of the work. So I'm keeping here the force multiplied by the displacement, and this is the cosine theta, and this is equal to 3750. And here I need to find the value of the force. Okay, so the force is equal to, this is the 3750, and divided by, this will go other side. Okay, the delta x and the cosine theta. So this is the delta x and multiply by the cosine theta. Okay, so what is the value of the theta? So we need to check the direction of the force and the direction of the displacement of the bullet. Okay, so if I go back to the figure, okay, so if I go back to the figure, now this is a bullet. Okay, and this is the direction of the displacement. Okay, this is moving in like in this direction. Okay, and here this is hitting, okay, to the wooden part, wooden surface here. So this is the direction of the force. So here the direction of the force and the direction of the displacement, they are parallel. Okay, so they have the angle of 0. So here I will keep the value, okay, 0 degree. So this is 3750, and the displacement value is how much? That is the 12 centimeter. Okay, or this value in meter. So this is the 12 multiplied by 10 to the power minus 2 meter, and this is the cosine 0 degree. The value of the angle is 0. So the force is equal to, okay, so if I calculate from my calculator, so how much it will come. Okay, so this will come approximately 31,000. Okay, so this is 31,250 Newton. So this is the answer for the force. And here this is the problem. So question number 9. The question number 9 is a 6 kilogram block starting from rest. Okay, so this is the, okay, so this is the box here, okay, in this diagram, and the box is starting from rest. Okay, so this is the rest position of the box. A 6 kilogram box starting from rest is pulled to the right side. Okay, is pulled to the right side. So this is the right side. This side is pulled to the right side on a frictionless horizontal surface by a constant force of 12 Newton. So this is the force applied on the box, and the value is given, that is 12 Newton. And determine the block's velocity after it has traveled 3 meter horizontally. So the box started from here and the box shifted up to here. Okay, so they are saying, okay, so they are saying this box has traveled the 3 meter distance, okay, or the displacement. So they are saying what is the velocity of the box, okay, what is the velocity of the box after it has traveled this 3 meter. Okay, so we have to find the velocity here. Okay, so how to do this problem? Okay, so what it is, given here. So what it is given here, so I'm writing, okay, the given parameters, okay, for this thing. It is given, okay, so they are saying this started from rest. So the meaning is the velocity, the initial velocity, okay, of the box is 0 meter over second. So here the value of the vi is given, that is 0 meter over second, and they are saying the mass, okay, the mass of the box is 60 kilogram, and also they are saying the force applied on the box is 12 Newton. So the force here is 12 Newton. Any other thing? Yeah. So the displacement also given, and this is 3 meter. Okay, so the value of the displacement also given, and this is 3 meter. And what we have to find, we have to find, okay, so here we have to find the velocity. Okay, actually this velocity we have to find at the end of this 3 meter. So we have to find what is the value of the vf. So we have to find what is the value of the vf. This is the question here. Okay, this is the question. So here they have given some, okay, the force and the initial velocity and the mass, something like this. Okay, so I can try, okay, so I can try the formula. Okay, I can try the formula, relation between the work, okay, the relation between the work and this half mass, and in the bracket this is the vf square and this is the vi square. Okay, so I need to find this, okay, so I need to find here this. I have the value of the mass, okay, I have the value of the vi, okay, so but I don't have the value of the work. Okay, so this also I need to find. Okay, so I will use my old formula, okay, for the work. I know, okay, the other rule, okay, for the work, and that rule, okay, for the work is, okay, for the work is the force multiply by the displacement and multiply by the cosine theta. Okay, so this is my old rule. So by using this rule, okay, I can find the value of the work here. Okay, so let us put all the values here, and the value of the force given, this is 12, and the value of the displacement is 3 meter, and the cosine theta is 0. Okay, why it is 0? Because this is the direction of the force, and this is the direction of the displacement. See, this is the direction of the displacement. Okay, the box is moving in this direction, so the angle between this arrow and this arrow is, they are parallel. Okay, so here the value of the theta is 0 degree. Okay, so I will put here 0 degree. Okay, then I will find the answer. Okay, how much answer is coming, let me calculate. Okay, so the cosine 0 is 1, and this will be, okay, so this will be 36 joule. So by using this rule, the value of the work is coming 36 joule. So what I will do now, okay, so what I will do now here, I will put this work value, okay, 36, okay, in this equation here. Okay, so if I say this is the equation number 1, so in this equation I will put the value of the, okay, work, that is 36 joule. So if I now here, this is the work and the half and the mass, and this is the v square, vf square minus the vi square, and this is coming 36 and equal to, okay, 1 by 2, and the mass of the box is how much? The mass of the box is 60 degree, is 60 kilogram. Okay, it is 60 kilogram, and the value of the vf we have to find. Okay, so this we have to find, and the value of the vi is 0. Okay, the power 2. Now I need to, okay, so this I will take other side. So this will be 36 multiplied by 2, and this 60 will come down, okay, here, and this is equal to vf square. Okay, so if I solve everything here, so it will be how much? This will be how much? Okay, so if I solve this one, so this will come 1.2 equal to, this is vf square. So here we need the value, here we need the value of the vf, not the vf square. Okay, so the vf is equal to under root, and this is 1.2. Okay, so if I keep the 1.2, okay, in the under root, so this will be 1.0. Okay, this is 1.09, this is meter over second. Okay, so this is the value of the final velocity. This is the value of the final velocity at the end of the displacement. So this is the answer here.